Hello, guys, and welcome to our last lecture for our subject, Advanced Database 2. So today we will be discussing about indexing, sharding, replication, and backup. With regards to the implementation of the codes, most of our implementation will only be done with regards to indexing, as the codes for sharding, replication, and backup requires installation of the actual MongoDB database. So let's get started. So when we say indexes support the efficient resolution of queries. As we have learned in our past lectures in SQL, indexes helps you make your queries faster. By specifying an index on one or more columns, we allow searching of the values to be faster, most especially if we are querying large amounts of data. Without indexes, MongoDB must scan every document of a collection to select those documents that match the query statement. This scan is highly inefficient and require MongoDB to process a large volume of data. Indexes are special data structures that store a small portion of the data set in an easy to transverse form. The index stores the value of a specific field or set of fields ordered by the value of the field as specified in the index. The create index method. To create an index, you need to use the create index method of MongoDB. The syntax for the create index method is db.collectionName.createIndex, open close parenthesis, what is the key or the column or the field name, colon, and then we have a value of either 1 for ascending and -1 for descending. Now, in this example, we will be creating an index for the mycall collection. So first, we will create or we will insert two records. So this is are the two records for our mycall or two documents. We have book 1 and book 2 having title and description. Now, if we are to create an index, we use again the command create index. So db dot collection name I call dot create index. First, we create an index on our title column. So title colon one. So this is ascending. Okay. After creating the code, what will happen? So let me refresh our database. So first, let us insert. So take note, if you are inserting more than one document, what you could do is to wrap them inside braces. And then all of your documents should be separated by curly braces, followed by a comma after the document has finished. So in this instance, we have two documents. So what I'm going to do is to execute. Okay, so we have inserted two records, and then I will create an index for title. Okay, so notice we have created our index. So num index before, num indexes after. Okay. Next, in create index method, you can pass multiple fields to create index on multiple fields or columns. You can also try to create an index on multiple fields or multiple columns. Okay, so I've created an index for title, which is ascending, and description, which is descending. The method also accepts a list of options, which are optional. Following is the list. So we have background, unique name, or the name of the index, parse. If true, the index only references documents within the specified field. Fire after seconds. Okay, and weight, which denote the significance of the field relative to the other index fields in the terms of score. We also have default language for text index and language override. If we want to remove the index, what we can do is to use the drop index command or drop index method. So the syntax for that is db dot collection name dot drop index and then open close parenthesis the name of our index. Okay. So notice, although we are dropping the index, we are still retaining the sorting by ascending or descending. Try that one. We will do this command. So drop index title colon 1. Okay. So we have dropped the index. So we can also delete multiple indexes using the drop indexes method. So the syntax is db dot collection name dot drop indexes. Okay. So if you want to drop indexes, you just enter the name of the column together with the sort order and then separated by comma for multiple fields. So for example, we will drop title and description as our index. Okay, so there you have it. You have created your index. But what if you want to return all the indexes found in your collection? In order for us to do that, we use the get indexes command. So the syntax is db dot collection name dot get indexes open close parenthesis. So in this example, again, we create our index. So for title and description, after doing that, we run the get indexes command and then it will return your index. Okay. So we have here title and then description. You have two indexes. What are those indexes? You have here index ID and then you have here the title and description index. Okay. So using get indexes, we can list all our available index. Okay. Next is aggregation. So aggregation operation process data records and return computed result. They group values from multiple documents together and can perform a variety of operations on the group data to return a single result. In SQL, count and with the group by is an equivalent of the MongoDB aggregation. So how do you use the aggregate method? The syntax is db.collection name.aggregate followed by the aggregate operation that you want to use. So for this example, we will be using collection name equal to. So we will be inserting three documents. Okay. So we have inserted three documents. Now what I'm going to do is to aggregate our document. First is by using sum. Okay. So in sum, it sums up all the defined value from all the documents in the collection. So in this example, we will be performing a sum operation on a sum operation on the by user column. Okay, so we will count all the by user columns and then okay, register and then it will have a column name of num tutorial. So let us try to run the command. Okay. So we have grouped our data by user. So meaning to say we will count. Okay, we will group it by user, and then we will count. Okay, so what I did is to delete the my call to collection. We were getting the wrong output simply because there are already datas there. So we will execute the insert statement for my call to again, and then let us refresh. Okay, so only three records are found. Then let us try to execute the result again. Okay. So what happens here is that we are grouping our data by or using the column by user. So we will count all. Okay, we will count all the records of our uh, document using by user. So in here, Neo4j only has one. And then we will name our sum as column num tutorial. In this example, tutorials tutorials point user has two documents. So num tutorial will have a value of 2, whereas num tutorial for Neo 4j will only have 1. So using this particular syntax, okay, sum colon 1, okay, sum colon 1. Next is average. So again, we will group it by user, and then the result will be stored in the column num tutorial. This one is if you are or if you still remember the as operator when you are renaming aggregate functions or computed columns, this is almost the same as that in SQL. Okay. In this instance, we will be doing an average of all the likes per user. Okay, so let's try to execute this one. Okay, so for Neo4j, we have 750, while for tutorial point, we have 110. So that's 110 divided by 2, or the average of 110, we got 55. Okay, for mean or the minimum value, it's almost the same as average. However, for min and max, we are getting the lowest value of like column. So that is 10 and 750. For max, that is 750 and 100. Okay, 750 and 100. How about push? So push inserts the value to an array in the resulting document. Okay. Push inserts the value to an array in the resulting document. So let us try to execute this one. So we have here URL colon push, then the value of URL. So let's try to run. Okay. So notice what happens here is that we are inserting the value of our column into an array, which in this instance is called URL. So that's why the value here for the URL is repeated. Okay, so that's the purpose of push. So notice for Neo4j, which only has one record, the URL was only displayed once because there's only one document or record. Whereas for tutorial points having two documents, the URL was inserted two times. Next is add to set, which inserts the value to an array in the resulting document but does not create duplicate. Let's try add to set. You notice the value of the URL was only inserted once if that particular value already exists. We also have first, which gets the first document from the source documents according to the grouping. Typically, this makes only sense together with some previously applied sort stage. And last gets the last document from the source document according to the grouping. Let us try first. So we will not notice any differences here because we have used the same value for the URL. The last. But let us try to modify this one. We can see the difference. Two, three, and then two. Okay, so we have inserted another documents for our URL. So let's try. Okay, so that is first. So it should be that first gets the first document according to the grouping, and then let's the last notice gets the last document according to the grouping. So those are our aggregate method. Pipeline concept. In Unix command, shell pipeline means the possibility to execute an operation on some input and use the output as the input for the next command and so on. MongoDB also supports the same concept in aggregation framework. There is a set of possible stages and each of those is taken as a set of documents as an input and produces a resulting set of documents or the final resulting JSON document at the end of the pipeline. This can then in turn be used for the next stage and so on. Following are the possible stages in aggregation framework. So we have here project. Just to select some specific field from my collection. We also have match, used for filtering operation. We have group, sort, skip, limit, unwind. So some of these concepts we have already tackled last lecture, especially the sort, the skip, and the limit. Replication. Replication is the process of synchronizing data across multiple servers. It provides redundancy and increases data availability with multiple copies of data on different database server. It protects the database from the loss of a single server. It also allows you to recover from hardware failure and service interruption. With additional copies of the data, you can dedicate one to disaster recovery, reporting, or backup. Why replication? It keeps our data safe. high 24/7 availability of data for disaster recovery, and then no downtime for maintenance like backup, index rebuild, and compaction, read scaling, extra copies to read from, and replica set is transparent to the application. So how does replication works in MongoDB? MongoDB achieves replication by the use of a replica set. It is a group of MongoDB instances that host the same dataset. In a replica, one node is the primary node that receives all write operation. The other instances, such as secondaries, apply operations from the primary so that they have the same dataset. A replica can have only one primary node. Replica is a group of two or more nodes. Minimum of three nodes are required. In a replica set, one node is the primary node and the remaining nodes are secondary. All data replicates from primary to secondary. At the time of automatic failover or maintenance, election establishes for primary and the primary node is elected. So it means to say that when there is failure or maintenance, one of the secondary is elected to become the new primary node. Okay? Maybe depending on the code or depending on the status or speed of the server. After the recovery of a failed node, it again joins the replica set and works as a secondary node. So once the old primary or previous primary node recovers, it now becomes part of the replica set as a secondary node. So that is how replication works. So this is the diagram. So client application driver reads and writes to the primary, and then all the written data are replicated to the secondary. A replica set features a cluster of n nodes. Any one node can be the primary. All write operations go to the primary. That's automatic failover and recovery, and consensus election of a primary node. How do we set up a replica set? This lesson, we will convert standalone MongoDB instance to a replica set. To convert to a replica set, the following steps are followed. First is shutting down the MongoDB server, and then start the MongoDB server by specifying dash dash the replica set option. So the syntax is MongoD dash dash port, and then the port number, and then the DB path or database path, and then replica set, and the name of the replica set instance. So for example, we have here, so we will start a MongoD instance with the name RSO on port 27017. Now start the command prompt and connect to this MongoD instance. In the Mongo client, issue the command initiate to initiate a new replica set. To check the replica set of configuration, issue the command conf. To check the status of the replica set, issue the command rs.status. Adding member to the replica set. To add members to the replica set, start MongoD instances on multiple machine. Now start the Mongo client and issue command rs.add. For rs.add host name and the port. For example, your instance name is Mongo d1.net running on port 27017. To add this to the replica set, we just use rs.add mongo1d.net colon 27017. Can only add a MongoD instance to the replica set when you are connected to the primary node. To check whether you are connected to the primary or not, we use the command db that is master in Mongo client. Sharding. Sharding is the process of storing data across multiple machines, and it is MongoDB's approach to meet the demands of data growth. As the size of the data increases, a single machine may not be sufficient to store the data, nor provide an acceptable read and write throughput. Sharding solves a problem with horizontal scaling. With sharding, you can add more machine to support data growth and the demands of read and write operation. So why do we choose sharding? In replication, all writes go to the master node Latency sensitive queries still go to the master. Single replica set has a limitation of 12 nodes. Memory can be large enough when active data set is big. Local disk is not big enough, and vertical scaling is too expensive. Sharding in MongoDB. So we have the application server here. So we have two app server, two or more app server routers, and we have two or more shards of a replica set, and then we have config server. So notice the data is passing back and forth from our app server to the config server to the shards. Shards are used to store the data to provide high availability and consistency. It, in a production environment, each shard is a separate replica set. So take note, each shard is a separate replica set. Config server, they store the cluster's metadata containing the mapping of the cluster's data set to the shard. The query router uses this metadata to target operations to specific shards. In production environment, sharded clusters have exactly three configuration servers, and the query routers are Mongo instances interface with client application and direct operation to the appropriate shard. The query router processes and targets the operation to the shards and then returns the result to the clients. The sharded cluster can contain more than one query router to divide the client load. A client sends request to one query router, generally a sharded cluster have many query router. And then our last topic is backup. So in order for us to do a backup in MongoDB, we use the mongodump command. So this command will dump the entire data of your server into the dump directory. There are many options available by which you can choose to limit the amount of data or create backup of your remote server. So the basic syntax is mongo dump. So to start your MongoDB server, assuming that your MongoDB server is running on localhost with port 27017, open a command prompt and go to the bin directory of your MongoDB instance and type the command mongo dump. The command will connect to the server running at localhost with port 27017 and back up all data of the server to the directory bin dump. So this is the example output of the command. We also have the available options. For example, we could specify the Mongo instance and the port. We could also specify the specific database that we want to back up together with the specified path. Or we could also back up only the collection of a particular database. To restore the MongoDB backup, we use the mongo restore command. So this is the output of the mongo restore command. So that ends our lesson for advanced database 2. Thank you guys and good luck.